Hi everyone, I hope you are doing well. In this session, we will be solving few problems on differential equations from previous year examinations. So let's begin. First problem is transformation to linear form by substituting v is equal to y power 1 minus n of the equation dy by dt plus p of ty is equal to q of ty power n greater than 0 will be. So by substituting v is equal to y power 1 minus n, then differentiating with respect to t, we have 1 minus n y power minus n dy by dt. That means that gives dy by dt is equal to 1 by 1 minus n y power minus n dv by dt. Now substituting in the given differential equation, we have, so substitute dy by dt as 1 by 1 minus n y power minus n dv by dt plus p of ty is equal to qt y power n. Now multiply multiply 1 minus n times y power minus n on both sides. We have dv by dt plus p of t 1 minus n y power minus n into y, or we can write this as 1 minus n is equal to qt 1 minus n and y minus n into y power n, that will be cancelled. Now since y power 1 minus n is equal to v, we get dv by dt is plus 1 minus n p times v is equal to 1 minus n times q. Now which is linear with v as dependent variable and t as independent variable. Okay. So answer is A. Let's go to the next problem. A spherical naphthalene ball exposed to the atmosphere loses volume at a rate proportional to its instantaneous surface area due to evaporation. If the initial diameter of the ball is 2 cm and the diameter reduces to 1 cm after 3 months, the ball completely evaporates in. Okay. So that means we can use law of decay here. So say dv by dt is equal to minus k times A, where V is the volume and A is the area, right? Because volume is rate of decay of volume is proportional to its surface area. Okay, that is why we took dv by dt is equal to minus k times a, where v is equal to 4 by 3 pi r cube and a is equal to 4 pi r square. Okay, so dv by dt is equal to 4 by 3 pi times 3r square and dr by dt. That is equal to 4 pi r square dr by dt. Let us substitute this here. Dv by dt is equal to minus k times a. So 4 pi r square dr by dt is equal to minus k 4 pi r square. Yes. So dr by dt is equal to minus k. Then we can take dt on the right hand side. Now integrating, we get r is equal to minus k times t plus c. Right? Now it is given initial diameter of the ball is 2 centimeter. That means at t is equal to 0, diameter is 2 centimeter, or at t is equal to 0, radius is 1 centimeter. Right? So at t is equal to 0, radius is 1 centimeter. Now substitute this value here in this equation. So we have 1 is equal to c. That means c is equal to 1. So we have our final equation as r is equal to minus k times t plus 1. So we have again one constant here. We have to find this k. So for that we have diameter reduces to 1 centimeter after 3 months. That means after 3 months diameter is 1 centimeter and radius is 0.5 centimeter. So at t is equal to 3 months, r is equal to 0.5 centimeter. Now let us put these values in here. So r is equal to 0.5 minus k times 3 plus 1. That means k is equal to minus 0.5 by minus 3, that is 0.5 by 3. So we have the final equation as r is equal to, the final rate of decay is equal to minus 0.53 times t plus 1. Now ball has to evaporate completely. So ball will completely evaporate when r is equal to 0. Okay, because when radius reduces to 0, that means putting r is equal to 0 when ball completely evaporates. So putting r is equal to 0 in the above equation and solving for t, this gives 0 is equal to 0.5 by 3 times t plus 1, that is 0.5 by 3 times t is equal to 1 and t is equal to 3 by 0.5. Right? Which gives 6 months. Okay, so answer is 6 months. In 6 months, ball will completely evaporate. Let us go to the next problem. The solution of the differential equation dy by dx plus 2xy is equal to e power minus x square with y is equal to 0, e is equal to 1 is. So, by inspection, we can say that this is a Leibniz linear equation, that is a first order linear differential equation. So, where this is in the form dy by dx plus p times y is equal to q, where p and q are the arbitrary function of x. So, integrating factor is equal to e power p dx, and that is 2x dx, which is equal to e power x square, and solution is y times integrating factor is equal to integral q times integrating factor dx plus c. Now y times e power x square is equal to integral e power minus x square e power x square, because q is e power minus x square and p is e power x square, so which will get cancelled. Dx plus c. So this will be 1 times dx plus c, which is equal to y e power x square is equal to x plus c. Okay. Now we are given initial values at x is equal to 0, y is equal to 1. So at x is equal to 0, y is equal to 1 given. So y is 1 and e power 0 is equal to 0 plus c. That means c is equal to 1. So the solution will be y e power x square is equal to x plus 1, or y is equal to x plus 1 times e power minus x square. Right? So this is the final solution. Okay. Now let's go to the next problem. For d square y by dx square plus 4 dy by dx plus 3y is equal to 3 e power 2x. The particular integral is, particular integral for of this form will be equal to 1 by d square plus 4 times d plus 3. This is the d square plus 4 times d plus 3, and 2 will operate on 3 e power 2x. And now since we know that f of d e power ax is equal to 1 by f of a e power ax, so pi will be equal to 3 e power 2x by 2 square plus 4 times 2 plus 3, that is 3 times e power 2x by 4 plus 8 plus 3, 15, that is by 2x by 55. Okay. So B B is the right answer. Let's go to the next problem. A body originally at 60 degrees Celsius cools down to 40 degrees Celsius in 15 minutes when kept in air at a temperature of 25 degrees Celsius. What will be the temperature of the body at the end of 30 minutes? Clearly this is from Newton's law of cooling. Okay, so from Newton's law of cooling we have d theta by dt is equal to minus k times theta minus theta naught. So this is in the variable separable form. So separating the variables, we have d theta by theta minus theta naught is equal to minus k times dt, and integrating on both sides we have ln theta minus theta naught is equal to minus kt d kt plus c. Let us say c dash, some constant. Now taking antilog on both sides, theta minus theta naught is equal to, so say we have, so we can write this as, first let us write this as plus, okay, then we can take this as theta minus theta naught by c equal to minus k times t. Now taking antilog on both sides, theta minus theta naught is equal to e power minus kt times c. Okay. Now theta is equal to theta naught plus c times e power minus kt. So now given 25 degrees Celsius, theta naught is 25 degrees Celsius, right? And at t is equal to 0, body had originally temperature at 60 degrees Celsius. Okay, so at t is equal to 0, at t is equal to 0, theta is equal to 60 degree, and 60 is equal to 25 plus c e power 0. So putting t is equal to 0 in this equation, okay. So we have c as equal to 60 minus 25, that is 35. Okay. So theta is equal to 25 plus 35 e power minus k times t. Okay. Now at t is equal to 15 minutes, theta is equal to 40 degrees Celsius. Okay. So 40 is equal to 25 plus 35 e power minus k times 15. So e power minus 15k is 3 by 7. Now question is, What will be the temperature of the body at the end of 30 minutes? Now at t is equal to 30 minutes, okay, at t is equal to 30 minutes, theta is equal to 25 plus 35 and e power minus 30k. So we can write this as 25 plus 35 e power minus 15k times 2. Okay, so now this can be replaced by 3 by 7. So 3 by 7, which will give 25 plus 35 times 3 by 7 whole square. And if you calculate this, so this will result in 31.5 degrees Celsius. Okay. Okay, so this was from Newton's law of cooling. What we did, the temperature, since the temperature of a body changes at a rate which is proportional to the difference in temperature of surrounding medium and that of the body itself, and then we replaced the proportionality by some constant k. Since there is the decrease, so we took we considered negative sign here, and then we solved the problem using variable separable method. Right? Let us go to the next problem. So there are two lists given, list 1 and list 2. Select the correct answer using the codes given below the list. So let us check the first one. So dy by dx is equal to y by x. So this is easily a variable separable method, dx by x. Now integrating both sides, we have log of y as equal to log of cx plus some constant c dash, which can be written as log c. So log y is equal to log of c times x, or taking antilog on both sides, we have y is equal to cx. This is the equation of a straight line, right, which is passing through origin with no intercept. So A is related to straight line. Okay. Next, let us check the dy by dx is equal to minus y by x. Okay. Again, we can take this as y on the left hand side and dx on the right hand side. Now this is log of y is equal to minus log of x plus log of c. Now taking antilog, first let us take log x on the left hand side. So this will be log y plus log x, that is log of y times x is equal to log of c. So yx, that gives yx is equal to c, and y is equal to c by x. Clearly this is equation of hyperbola. Okay. Okay, so b is related to hyperbola. Now let us check this. Dy by dx is equal to x by y. Right? So y dy is equal to x dx. Integrating on both sides we have y square by 2 is equal to x square by 2, right? And plus some constant c dash, and which can be written as c square by 2, some constant, and then y square by 2 minus x square by 2 is equal to c square by 2, which can be rewritten as y square by c square minus x square by c square is equal to 1. So this is also equation of a hyperbola. Okay. C is also related to hyperbola. Next, dy by dx is equal to minus of x by y. Dy by dx is equal to minus xy by y, which is y dy integral is equal to minus x dx. So y square by 2 minus plus x square by 2 is equal to c square by 2, which is x square plus y square is equal to c square. So clearly this is the equation of circle with origin as the center and c as the radius. So D is related to circle, right? So answer is A. Okay. Now let us go to the next problem. The order and degree of the differential equation. Okay. So let us remove this radical first. So dq by y dx cube, let us write this as taking squares on both sides, we have d cube y by dx cube whole square is equal to 16 dy by dx whole cube plus y square. Okay, the order is 3 since the highest derivative is 3 d cube y by dx cube. So the degree is 2 since the power of highest derivative is 2, right? Degree 2 and order is 3. So answer is A. Okay. Let us go to the next problem. the function nx satisfies the differential equation d square nx by dx square minus nx by l square is equal to 0, where l is a constant. The boundary conditions are n is equal to at x is equal to 0, n is equal to k, and at x is equal to infinity, n is equal to 0. Now the auxiliary equation is d square minus 1 by l square is equal to 0. Solving for d, we have d is equal to plus minus 1 by l, since this is in the form of a square minus b square. Then solution is c1 e power minus 1 by lx plus c2 plus 1 by l, right? Okay. Now at n is equal to 0, x is equal to 0, n is k. So at x is equal to 0, we have c1 plus c2 is equal to k, and at x is equal to infinity, we have c1 e power minus infinity plus c2 e power plus infinity is equal to 0. So e power minus infinity is 1 by e power infinity, and that is 0. So we have only c2 e power infinity, that is equal to 0, and c2 is equal to 0. That means c2 is equal to 0, and c1 is equal to, now from this c1 plus c2 is equal to k, we have c2 is 0, so c1 will be equal to k. Then the solution is nx is equal to k e times minus 1 by l times x. Okay. The answer is A here, right? So with initial condition x at 1 equal to 0.5, and the solution of the differential equation t dx by dt plus x is equal to t. Dividing t on both sides, we have dx by dt plus x by t is equal to 1. So which is a linear differential equation? So comparing this with dx by dt plus p times x is equal to q, p is equal to 1 by t and q is equal to 1. So integrating factor is integral p dt. So integral 1 by t dt, which is e power ln t, right? And this is equal to t. Now the solution is integrating factor is equal to q times integrating factor dt plus c. So x times t is equal to q is 1, t times dt plus c. So xt is equal to t square by 2 plus c. Now x is equal to t by 2 plus c by t. Now with initial condition t is equal to 1, x is 0.5. So x at 1 is 1 by 2. Putting this in equation here, so we will have 1 by 2 plus c by 1 is equal to 1 by 2. that keeps c is equal to 0. That means x is equal to t by 2 is the solution. Fine, let us go to the next problem. The solution of differential equation where k is constant, subjected to boundary condition, u at 0 is 0, u at L is u. Right? So given is a second order differential linear differential equation. So here complete solution will be equal to complementary function since there is 0 on the right hand side. So now we have to find complementary function. So given d square minus k times d u is equal to 0. So the auxiliary equation is m square minus km is equal to 0. So m is equal to 0 and k. So complementary function is u is equal to c1 e power 0x plus c2 e power kx. c1 plus c2 e power kx. Now using boundary condition, okay, u at 0 is 0. So put x is equal to 0. Zero is equal to c1 plus c2 e power 0. That means c1 is equal to minus c2. And using at x is equal to L, u is capital U. E power kl. Now using this and this, we have u is equal to minus c2 plus c2 e power kl. That means c2 is equal to minus 1 or e power kl minus 1 is equal to u. Then c2 is equal to u by e power kl minus 1. Yes. Now we need to find small u with respect to capital U. Okay, right. So this can be written as C2. Let us delete. We don't have a space here. So from here C2 is equal to, if you multiply divide by e power minus e power kl, okay, e power kl, so 1 by minus e power minus kl, that is e power minus kl times u. Now C1 will be equal to minus C2. So minus e power minus kl times u by 1 minus e power minus kl. Okay. Now we have the values of C1 and C2. Now let us put these values in here. Right? So u will be equal to capital U C1 plus C2 e power kx. So minus e power minus kl by 1 minus e power minus kl. So this is C1 plus C2. C2 is e power minus kl times u by 1 minus e power minus kl. And then e power kx. Right? Now taking LCM we have so if you solve this you will get capital U 1 minus e power minus kl minus e power minus kl plus e power minus kl e power kx. Now take e power minus kl common. So e power minus kl, if you take common, so we will have minus 1 plus per kx by 1 minus e power minus kl. Now, so if you multiply, if you divide e power minus kl in the numerator and denominator as well, so you will have e power minus kl and e power minus kl. So this will get cancelled and this will also get cancelled. So this will be e power kl minus 1. Okay. Then okay, we have 1 minus. So if you take minus common, so this will be minus and this will be 1 minus e power kl. So now we have got the final answer. Okay, this is capital U. Right? So this is the answer. So B is the right answer. Okay. Let us go to the next problem. The maximum value of the solution y of t of the differential equation yt plus y double derivative of y with respect to t is equal to 0 with initial conditions and for t greater than equal to 0 is. So this is nothing but, if you take the auxiliary equation, so we will have 1 plus d square is equal to 0. So this is the auxiliary equation. Solving, we have d is equal to plus or minus I. Okay, now y will be equal to c1 e power plus ix plus c2 e power minus ix. Then this will be equal to a times cos x plus b times sin x. Now conditions are y is equal to 0, y at 0, t is equal to 0 is 1. So y at t is equal to 0 is 1. So a cos 0 plus b sin 0. So this is 1 is equal to a times 1 plus 0. That means a is equal to 1. Now first derivative of y, first we have to find first derivative of y. So y dot is a derivative of cos x is minus sin x, so minus a sin x, and derivative of sin x is cos x, so plus b cos x. Now we have first derivative of y. So at t is equal to 0, this is 1. So minus a sin 0 plus b cos 0. So this is that means b is equal to 1, right? Now we have to find the maximum value of the solution. Before that, let us write the final solution. So a is equal to 1, b is equal to 1, that means cos x plus sin x. The final solution is cos x plus sin x. Now for maximum value, we need to find the first derivative of y, right? So we have to work on this equation. So dy by dx is equal to minus sin x plus cos x. Equate this to 0. So we will get sin x is equal to cos x, and sin x is equal to cos x at x is equal to 45 degree. Now double derivative of y with respect to x will be equal to minus of cos x plus minus sin x. Now at x is equal to 45, y double dash is less than 0, because if you write minus as cos 45 plus sin 45, which is negative value. So that means we have a maxima at 45 degree. Okay. So at 45 degree we have a maxima, and the value is cos 45 plus sin 45, that is 1 by root 2 plus 1 by root 2, that is 2 by root 2. So root 2. So root 2 is the right answer. Okay, let's go to the next problem. The general solution of the differential equation dy by dx is equal to cos of x plus y with c as a constant is. Let x plus y as z. Then dz by dx is equal to 1 plus dy by dx. Now dz by dx minus 1 is equal to cos dz minus dx dy by dx is equal to dz by dx minus 1 is equal to cos of z. Now integrating both sides, dz by, take this here, one plus cos z is equal to, we know that cos z is equal to 2 cos square z by 2 minus 1, or 1 plus cos z is equal to 2 cos square z by 2, right? So we have 1 by 2 integral 1 by cos square z by 2, which is equal to sec square z by 2, dz is equal to x plus c. Now integral of sec square z by 2 is equal to 1 by 2 tan z by tan z by 2 whole divided by 1 by 2. 1 by 2 gets cancelled, is equal to x plus c. Now putting back the value of z, we have tan of z by 2, that is x plus y by 2, is equal to x plus c. So this is the required solution. So D is the right answer. Let us go to the next problem. Consider the differential equation x square d square y by dx square plus x dy by dx minus y is equal to 0. Which of the following is a solution to the differential equation for x greater than 0? Let us put x is equal to e power z, or z is equal to log of x. So now x d by dx operator is equal to x times capital D, which is equal to theta, and x square d square is equal to theta times theta minus 1. Now, so this equation can be rewritten as x square d square plus x times d minus 1 now. So this can be replaced by theta times theta minus 1 plus theta minus 1. So this is the auxiliary equation. Now solving, we have theta square minus theta plus theta minus 1, or theta square minus 1 is equal to 0. That means theta is equal to plus or minus 1. Then the complementary function is c1 e power minus z plus c2 e power z. Now we had put e power z as x, replacing c1 x power minus 1 plus c2 x. So the complementary solution is c1 by x plus c2 times x, right? So one independent solution is 1 by x and another independent solution is x. So here C is the most appropriate answer, right? Let us go to the next problem. Consider two solutions. Xt is equal to x1t and xt is x2t of the differential equation, such that x2 is equal to 0 at dx2t by dt at t is equal to 0 is equal to 1. The Wronskian wt at t is equal to pi by 2 is. Okay, so we have to find the Wronskian. So given the auxiliary equation is d square plus 1 is equal to 0, then d is equal to plus minus I, then complementary function will be equal to c1 cos t plus c2 sin t. Yes. We have to consider two solutions x1t and x2t such that x2 is equal to 0 at t is equal to 0. So at t is equal to 0, this is equal to c1 which is not equal to 0, and at t is equal to 0, this is equal to 0. That means this is x2. So this is equal to x1t plus x2t, right? Now x1t is equal to c1 cos t, and at t is equal to 0, this is equal to c1 right, and x2 at 0 is 0 c2 sin 0, right? Because sin 0 is 0. And derivative of x2 is c2 cos t, which is equal to 1. That means at t is equal to 0, c2 is equal to 1, right? That means x2t is equal to sin t. Okay. Now the Wronskian is x1t, x2t, d of x1t by dt, d of x2t by dt, so equal to cos of t sin t, so minus sin t, and derivative of sin t is cos t. So which is equal to cos square t minus sin square t, that is plus sin square t, which is equal to 1. So Wronskian is equal to 1. So 1 is the right answer. Let us go to the next problem. Consider the following difference equation. Which of the following is the solution of the above equation? Okay, C is an arbitrary constant. Let us take this on the left hand side and this on the right hand side, right? So y dx plus x dy by x dy minus y dx is equal to y by x tan of y by x. Right? Now this is clearly a homogeneous function. So to solve, let us put y is equal to vx, then dy by dx is equal to v plus x dv by dx, or dy is equal to v dx plus x dv. Now putting y is equal to vx in this equation, vx dx plus x dy. So dy is v dx plus x dv. So vx dx plus x square dv by vx dx plus x square dv minus vx dx is equal to v tan v. Okay. Now see, vx dx plus vx dx is 2vx dx plus x square dv by, this gets cancelled and we have x square dv is equal to v tan v. So we can cancel x. So 2v dx plus x times dv is equal to x dv. So cancelling x from numerator and denominator, v tan v. Okay, this is 1 plus 2v by x dv dx by dv is equal to v tan v. Taking 1 on the right hand side, so minus 1. And we can take v on the right hand side. 2 dx by x is equal to tan v by v. So we get cancelled, minus 1 by v dv. Now this is in the variable separable form. So integrating both sides, this is 2 times log x is equal to log of secant v minus log of v plus some constant c, which can be written as log of some constant c. So this is log of x square, taking 2 on the power. So that means x square is equal to secant v times c by v. So c times secant v, let us write log c times secant v by v. So taking anti-log on both sides, right? Now again putting back the value of y, v, that is y by x. So we have x square y by x is equal to c secant y by x. That gives xy cos of y by x is equal to c. So this is the, c is the right answer. Okay, let us go to the next problem. The general solution of the differential equation dy by dx is equal to 1 plus cos 2y by 1 minus cos 2x is. Okay, so this can be written as dy by 1 plus cos of 2y is equal to dx by 1 minus cos 2x. So this is in the variable separable form, so we can integrate on both sides. So this is nothing but 2 cos square y, 2 cos square y and this is 2 sin square x. Why? Because we have cos 2y as 2 cos square y minus 1, and cos 2y is also equal to 1 minus 2 sin square y. So here this is x, we can take x, right? So from here we can conclude that 1 plus cos 2y is equal to 2 cos square y and 1 minus cos 2x is 2 sin square x. Now integrating on both sides, we have sec square y integral cosec square x dx. So now integrating, we have tan y is equal to minus cot x plus some constant c. So that means tan y plus cot x is equal to c is the solution of this differential equation, right? So this matches our answer. C is the right answer. Let us go to the next problem. Find the solution of d square y by dx square is equal to y, which passes through the origin and the point ln 2 3 by 4, right? So d square y by dx square is equal to y. That means we have auxiliary equation as d square minus 1 is equal to 0. So d is equal to plus or minus 1. So y is equal to, the complementary solution is equal to c1 e power x plus c2 e power minus x. Now given that a point passes through the origin, okay, so at x is equal to ln 2, we have y as 3 by 4. So this is y is equal to 3 by 4 at ln 2 that gives C1, 2c1 plus c2 by 2. Yes, and c2 plus 4c1 is equal to 3 by 2, that is 1.5, right? And since the point all that this equation also passes through the origin. That means at x is equal to 0, y is also equal to 0. So 0 is equal to c1 e power 0 plus c2 e power minus 0. That is 0 is equal to c1 plus c2. So c1 is equal to minus c2. Now we have two equations, 1 and 2. Solving, so putting c1 is equal to minus c2 in equation 1, so minus c2 plus, we have c2 minus 4c2, okay, is equal to 1.5. So that is minus 3c2 is equal to 1.5. So c2 is equal to 1.5 by 3, that is minus 0.5, and c1 will be equal to minus of minus 0.5, that is 0.5. So y is equal to 0.5 e power x minus e power minus x. So that means C is the most appropriate answer. Okay. Let us go to the next problem. The differential equation d square y by dx square plus 16y is equal to 0 for y of x with the two boundary conditions. So, right? So that this yx has no solution, exactly two solutions, exactly one solution, or infinite many solutions. So let us check this. So auxiliary equation is m square plus 16 is equal to 0. So m is equal to plus minus 4i. Then the complementary function or the solution will be equal to y is equal to c1 cos 4x plus c2 sin 4x. Then differentiating with respect to x, we have minus 4 c1 sin 4x plus 4 c2 cos 4x So at 0, at x is equal to 0, y dash is equal to 1, that is, this is sin 0 is 0, so this will be equal to 4 c2 cos 0, that is 4 times c2, cos 0 is 1, so that gives c2 is equal to 1 by 4. Again at x is equal to pi by 2, so y is equal to c1 cos 2x, cos 2 pi, okay, we have to put in this equation, right? This is equal to minus 4c1 sin 2 pi plus 4c2 cos 2 pi, and this is equal to minus 1 at pi by 2 is equal to minus 1. So minus 1 is equal to, so at sin 2 pi is 0, so 0 plus 4c2 cos 2 pi, that is cos 2 pi is 1, so 4c2. So we have c2 as equal to minus 1 by 4. So we have contradictory values for c2, that is 1 by 4. Look here, so c2 is 1 by 4 and c2 is minus 1 by 4. So c2 cannot have both the value, cannot take both the values 1 by 4 and minus 1 by 4 at the same time. So therefore the given differential equation has no solution, right? Let us go to the next problem. Consider the differential equation t square minus 81 dy by dt plus 5t y is equal to sin t. With y at 1 is equal to 2 pi, there exists a unique solution for this differential equation when t belongs to the interval. So we have to find out the interval. Okay, so let us divide t square minus 81. Let us divide throughout by t square minus 81. So dy by dt will be equal to 5t by t square minus 81 y is equal to sin t by t square minus 81. So this is linear Leibniz form. Where p is equal to 5t by t square minus 81 and q is equal to sin t by t square minus 81. So integrating factor is equal to e power integral p dt, that is e power integral 5t by t square minus 81 dt right. Now let us take 5 out, integral, let us multiply and divide by 2 dt. Now let us take t square minus 81 as say z, then 2t dt will be equal to dz, and then this can be replaced by e power 5 by 2 integral dz by z. So that is equal to e power 5 by 2 ln z, integral of 1 by z is equal to L log of z. So ln z is equal to t square minus 81, right? And we can take this 5 by 2 on the power here. So this is equal to e power ln t square minus 81 power 5 by 2. That means integrating factor is t square minus 81 power 5 by 2. Right? Now the solution is y into integrating factor, that is 2t square minus 81 power 5 by 2 is equal to integral sin t q t square minus 81. So q times integrating factor, that is t square minus 81 power 5 by 2 dt. So this is equal to sin t square minus 81 5 by 2 minus 1, that is 3 by 2. Yes, dt. And here this is by t square minus 81 power 5 by 2. Right? And if you take this on the right hand side in the denominator, so sin t square minus 81 3 by 2 dt. So say if you integrate this, then you will get some constant c, and by t square minus 81 5 by 2 t square minus 81 5 by 2. Then the solution exists only if, so if t is equal to 9, if t is equal to 9, right, or t is equal to minus 9, so that means this is denominator is equal to 0, that means no solution exists, right? So the interval should not involve plus 9 or minus 9. So B cannot be the answer, D cannot be the answer, C cannot be the answer. Only A is the right answer. Okay? Got it? Let's go to the next problem. Which one of the following is the general solution of the first order differential equation x plus y minus 1 whole square is equal dy by dx is equal to x plus y minus 1 whole square? So we can solve this by taking this form can be reduced to variable separable form by putting x plus y minus 1 as some constant, some another variable t, say t, then 1 plus differentiating with respect to x, 1 plus dy by dx is equal to dt by dx. Then dy by dx is equal to dt by dx minus 1. Now substituting this in the original equation, so dt by dx minus 1 is equal to t square. Now dt by, this can be taken on the right hand side, plus 1. So dt by t square plus 1 is equal to dx. Now integrating on both sides, we have tan inverse t is equal to x plus c. Right? Now since t is equal to x plus y minus 1, so replacing tan inverse x plus y minus 1 is equal to x plus c. So x plus y minus 1 is equal to tan of x plus c, and y is equal to 1 minus x plus tan of x plus c. So this is the required solution. So answer is D. Okay. Let us see the next question. the respective expressions for complementary function and particular integral part of the solution of the differential equation given by R. The given differential equation is d power 4 plus 3d square y is equal to 108 x square, where d is the operator d by dx. Then auxiliary equation is given as m power 4 plus 3m square is equal to 0. Taking m square as common, m square plus 3 is equal to 0. So m is equal to 0. We have repeated roots and plus minus root 3 I. Now the complementary function is equal to c1 plus c2 x plus c3 sin root 3x plus c4 cos root 3x. And particular integral part, we have to operate 1 by d power 4 plus 3d square on 108 x square. Now, since we know the binomial expansion of 1 plus minus x power plus minus n, which is easy to expand, okay, so make this denominator in the form of 1 plus minus x power plus minus n. Okay, so we will see that when operated on this function, higher power in the expansion vanishes. So let us take out 3d square common. So we will be left with 1 plus d square by 3. So on the other hand, we could have taken d power 4 as common, then 1 plus 3 times d square by d power 4, right? Then we will have the expansion in 1 by d square, and the expansion of this would consist of the power of 1 by d square power n. That way we would be making it complex, right? So since higher order derivative, calculating higher order derivative is easier, so that is why we will take 3d square as common, 1 plus d square by 3 and 108 x square. Right? So this is 108 by 3, 36 by d square, and 1 plus d square by 3, taking this in the numerator, so minus 1. So this will be operated on x square. Now expand this. So we know that expansion of 1 plus x power minus 1 is 1 minus x plus x square minus x cube and so on, right? So 36d square, 1 minus d square by 3 plus d square d power 4 by 9 and so on. Which will operate on x square. So again, (36 by d square x square minus double derivative of x square is, first derivative is 2 times x and second derivative will be equal to 2. So minus 2 by 3. Then obviously fourth order derivative, third order derivative it will be 0, and then higher order derivative vanishes. So just x square minus 2 by 3 plus 0. Right? Now, say this is 1 by d square, means inverse operator. Now, let us clear. Okay, so 1 by d square is integral, double integral 36 x square minus, sorry, why I am taking 36 inside, let us take 36 is outside, and 36 double integral x square minus 2 by 3 dx and dx. Again this will be 36 x bar, for integrating once it will be x cube by 3 minus 2 by 3x. Again integrating we will have x bar 4 by 4 into 3 minus 2 by 3 x square by 2. That gives 3x bar 4 minus 12 x square. Yes? So we have complementary function as c1 plus c2x plus c3 sin root 3x plus c4 cos root 3x, and particular integral as 3x bar 4 minus 12x square, obviously plus constant, plus c. Yes, so A is the right answer. Let's see the next question. Consider the following second order differential equation: y double dash minus 4y dash plus 3y is equal to 2t minus 3t square. Okay, the particular solution, we need to find particular integral of this differential equation. So writing directly as, so auxiliary equation is d square minus 4d plus 3. So d square minus 4d plus 3, this will operate on 2t minus 3t square. Right? Again, factorizing this, d square minus 4d plus 3 is, so 1 minus d and 3 minus d. Yes. Again, we can find out A and B such that this is equal to this plus this. So for 1 minus d, multiply by 1 minus d and put d is equal to 1. Then this will be equal to 3 minus 1, that is 1 by 2. So a is 1 by 2. And for b, to find out b, put d is equal to multiply 3 minus d, and then this will get cancelled, and then put d is equal to 3, then this will be equal to minus 1 by 2. So this is equal to minus 1 by 2, right? Okay, so and into 2t minus 3t square, right? Now this can be written as, if I take 3 common here, so this will be equal to 1 minus d by 3. Yes, so now we have half 1 minus d power minus 1, 2t minus 3t square, minus 1 by 6, 1 minus d by 3 power minus 1, 2t minus 3t square. Now expanding 1 minus d power minus 1, so 1 plus d square half on 2t minus 3t square minus 1 by 6, and expansion of 1 minus d power 3, d by 3 whole power minus 1, 1 plus d power 3 plus d square by 9, and so on, right? And this will operate on 2t minus 3t square. Again half, so multiplying 1 by 2t minus 3t square, so 2t minus 3t square, then d derivative of 2t minus, first derivative of 2t minus 3t square is plus derivative of 2t minus 3t square, so which is two minus 6t, and then again double derivative of 2t minus 3t square is first derivative of 2 minus 6t, that is minus 6, and then subsequent higher order derivative will be equal to 0. So higher order derivative greater than 2 will be equal to 0. So for this part we have calculated, right? Okay, so and for the second part, minus 1 by 6, 1 times 2t minus 3t square, 1 minus multiplying 1 by 2t minus 3t square, then derivative d by 3, so 1 by 3 is common, plus d first derivative of 2t minus 3t square, that is 2 minus 6 times 2 minus 6t. Yes, again t square, so taking 1 by 9 common, and d square of double derivative of 2t minus 3t square. So differentiating this twice is nothing but, we have already differentiated it once, so differentiating it once again with respect to t, we will have minus 6. So this is minus 6 by 9. Okay, now Simplify. 1 by 2, 2t minus 3t square plus 2 minus 6t minus 6. So this is minus 4t and this is 2 minus 6 is minus 4. Right? And this is minus 1 by 6, 2t minus 3t square, 2t minus 3t square plus 2 by 3 minus 2t and minus 6 by 9. So 2t minus 2t gets cancelled, then minus 3t square, and this is 6 by 9 is 2 by 3, so this gets cancelled. So we are left with only minus 3t square. Right? Then finally we have, so minus 3t square by 2 and minus 3t square by 6, so which is minus t square, and minus 2 is minus 2 only, and minus 2t is minus 2t. So this is the final answer. Minus t square, minus 2 and minus 2t. Right? Okay, let's see the next question. A curve passes through the point x is equal to 1, y is equal to 0 and satisfies the differential equation. The equation that describes the curve is. So dy by dx is equal to x square plus y square by 2y plus y by x. This is clearly homogeneous, so we can put y is equal to vx. Then dy by dx is equal to v plus x dv by dx. Then putting y is equal to vx in this equation, we have v square x square plus x square, that is taking x square common, x square v square plus 1 by 2 times vx plus v is equal to dy by dx, or dy by dx is equal to v plus x dv by dx. So plus v minus v gets cancelled. So this x gets cancelled and this x gets cancelled again. So we have dv by dx as v square plus 1 by 2v. Now this is in the form of variable separable method. So we will apply variable separable. So 2v by v square plus 1 integral dv is equal to integral dx. Then taking v square plus 1 as t, so v square plus 1 is t, then 2v dv is equal to dt, right? So this is nothing but dt by t integral x plus c. Again this is nothing but log x log t is equal to x plus c. Now putting back value of t, okay, so that is log 1 plus v square is equal to x plus c. and we had assumed y is equal to Vx, then V is equal to y by x. So putting V is equal to y by x in this equation, so we have log 1 plus y by x whole square is equal to x plus c, and this curve passes through the point x is equal to 1 and y is equal to 0. So at x is equal to 1 we have y as 0. So this is 1 plus 0 by 1, that is log 1, which is 0, is equal to 1 plus c. So that means c is equal to minus 1. So we have the final answer as log 1 plus y square by x square is equal to x minus 1. Okay, let us go to the next question. The solution of the differential equation x square d square y by dx square minus x dy by dx plus y is equal to log x is. Okay, so this is x square d square minus xd plus 1 is equal to log x. Now put x is equal to e power z, then xd is equal to theta, right? And z is equal to log x. Then x square d square is equal to theta times theta minus 1. Then the auxiliary equation, modified equation will be theta plus 1 y is equal to z, and auxiliary equation will be equal to, let us simplify this first. So theta square minus theta, that is 2 theta plus 1 is equal to 0. So this is the auxiliary equation, and roots are theta is equal to 1 and 1. So repeated roots. Then we have the complementary function as y is equal to c1 plus c2 times z e power z. Okay, and z is log x and e power z is x. So this is c1 plus c2 log x times x right. Now to find out the particular integral for pi, let us say the operator is 1 by, so this is theta minus 1 whole square. Let us take the operator as d dash minus 1 square and log x, which is z. Okay, so now this is 1 minus, so we can write this as 1 by 1 minus d dash whole square which gives 1 minus d dash power minus 2, and this will operate on z. And we know that binomial expansion of 1 minus x power minus n is 1 plus nx plus n times n plus 1 by 2 factorial x square plus n times n plus 1 times n plus 2 by 3 factorial x cube and so on. Right? Okay, we don't have much space. So expanding using binomial expansion, so we have 1 plus 2 d dash plus 2 times 2 plus 1, that is 3 by 2 factorial x square, I mean d square, d dash square, and so on. Right? So this will operate on z, and we know that order greater than 1, power of order greater than 1 will be equal to 0. So we will ignore powers of order greater than 1. Z. Yes. So this is nothing but z plus derivative of z, so that is 2. 2 times 1, that is 2, z plus 2. So particular equation, particular integral we have z plus 2, then the complete solution will be equal to complementary function plus particular integral, that is c1 plus c2 z or c1 plus c2 log x times x plus z is log x, so log x plus 2. Yes. So this is the complete solution. Then D is the right answer. Now let us go to the next problem. Consider the differential equation dx by dt is equal to sin x with the initial condition x is equal to x at 0 is equal to 0. The solution to this ordinary differential equation is, okay, so given differential equation is dx by dt is equal to sin x. So we can take sin x to the left hand side. So dx by sin x integral dt. So taking integral on both sides. Now we can write this as 1 by integral 1 by sin x as integral cosec x. Now multiply and divide by cosec x plus cot x, cosec x plus cot x, right, which is equal to cosec square x plus cosec x cot x whole divided by cosec x plus cot x. Now multiply by minus 2 times minus cosec square x, okay, and that will give minus cosec x square x minus cosec x cot x by cosec x plus cot x. Now let us assume cosec x plus cot x as u. Then differentiating with respect to x on both sides. So we have minus cosec x cot x and minus cosec square x is equal to du. Now I think we are clear why we multiplied and divided by cosec x plus cot x. So now this becomes minus 1 by u du. And integrating, we are well aware integration of 1 by u is log u plus c, right? And with original substitution of u is equal to cosec x plus cot x back into this expression, we have minus log cosec x plus cot x plus c. Yes? Then so 1 by sin x integral we have. Let us clear this. So we have log minus cosec x plus cot x plus some constant, so which can be taken on the right hand side, so t plus c. Okay, say this is c dash and we took minus c here, and this is another this makes another constant which is c1. Okay, now taking anti-log on both sides, we have e power minus t plus c is equal to cosec x plus cot x, right? So I took this minus sign here on the right hand side. Okay, now cosec x is 1 by sin x and cot x is cos x by sin x, right? And we know that cos square x can be written as cos 2x, cos x can be written as 2 cos square x by 2 minus 1. So 1 plus cos x is 2 cos square x by 2, and sin x is, we can write sin x as 2 sin x by 2 cos x by 2. So this is cos x by 2 and sin x by 2. Okay, then taking reciprocals on both sides, so this is this will become e power t plus c, and this will become tan x by 2, right? Then x by 2 is equal to tan inverse e power t plus c, right? Now we are given an initial condition at t is equal to 0, x is 0. So at t is equal to 0, this x is 0, so 0 is equal to tan inverse e power 0 plus c That means tan 0 is equal to e power 0 plus c, that is 0, and for e power c to be 0, c should be minus infinity. So since e power minus infinity is 1 by e power infinity and that is 0, so c is equal to minus infinite. Then solution is x by 2 is equal to tan inverse e power t minus infinite, right? And since t is greater than or equal to 0 and finite, so t minus infinity can be approximated to minus infinite, and then we get x by 2 is equal to tan inverse e power minus infinite. Then x by 2 is equal to 0, that gives xt is equal to 0. Then the solution to this ordinary differential equation is A. Let us see the next question. If u is equal to x log xy and where x cube plus y cube plus 3xy is equal to 1, then du by dx is, right? So let us find first partial derivative of u with respect to x, so which will be x, then derivative of xy log xy, which is 1 by xy into y, plus log xy and dx by dx, that is 1, so which is equal to 1 plus log xy. Again, taking a partial derivative of u with respect to y, x log xy, so this is in the u into v form, so x into 1 by xy into x plus zero because this is actually log xy times dx by dy, which is 0. Then this is x by y. Okay, now differentiating this equation with respect to x, so x cube plus y cube plus 3xy is equal to 1, so we have 3x square plus 3y square dy by dx plus 3x dy by dx plus y dx by dx is equal to 0. Then dy by dx (3y square dy by dx) Okay, taking dy by dx as common, 3y square plus 3 times x plus 3x square plus 3y equal to 0. Then dy by dx will be equal to minus 3x square minus plus y by y square plus x So we have the values of del u by del x, del u by del y and del y by del x. Sorry, dy by dx. Now by total differentiation concept we know that du by dx is equal to del u by del x plus del u by del y times dy by dx. Now putting the respective values in this equation, we have, so del u by del x is 1 plus log xy and del u by del y is x by y and dy by dx is minus x square y by y square plus x. So this is minus x by y times x square plus y by y square plus x. So this is the required answer. Okay, du by dx is equal to 1 plus log xy minus x by y. Okay, so C is the right answer. Let us see the next question. The solution of differential equation del cube z by del x cube minus 3 del cube z by del x square by del y into del y plus 4 del cube z by del y cube is equal to e power x plus 2y is. Okay. Okay, so writing del by del x as d, del by del y as d dash. So we get d cube minus 3 d square d dash, because there is a double derivative of x with respect to x and single derivative with respect to y, plus 4 times d dash cube. Z is equal to e power x plus 2y. Okay, now auxiliary equation is m cube minus 3m square plus 4 is equal to 0, and factorizing we get m plus 1 m minus 2 whole square is equal to 0. So m is equal to minus 1 and 2 repeated roots at 2. So complementary function is f1 y minus x plus f2 y plus 2x plus x, f3 y plus 2x. Okay, and for particular integral we have this operator on e power x plus 2y by, so 1 by d cube minus 3d square d dash plus 4 times d dash cube e power x plus 2y. Now so put d cube, put d as 1 because coefficient of x is 1 and d dash as 2, right? So again we have 1 by 1 cube minus 3 times 2 square into 1, that is 1 into 1 square times 2 plus 4 times 2 cube e power x plus 2y. Hence, solution is 1 by 1 minus 6 plus 32, that is 27. So this is the complete solution. Z is equal to complementary function plus particular integral. So this is particular integral and this is complementary function part. So adding, we have final solution as f1 y minus x plus f2 y plus 2x plus x f3 y plus 2x and plus e power x plus 2y by 27. Okay. So answer is A. So this is how we proceed if the differential equation type is of this kind. Okay. Since m is equal to minus 1 and 2 and 2, that is why we are taken here minus 1x plus 2x and plus 2x. Okay. And since the repeated roots are there, that is why we multiplied one function by x, right? So this was the last question. In the next lecture, we will start partial differential equations and then we will learn complex functions, right? Till then, keep preparing. Thank you.